Alright, so 3.5 is rational functions and their graphs. And so I'm going to take this video. This is a longer lesson, guys, and I'm sorry, it just is what it is. But I'm going to chunk it into sections, okay? I just recorded a really long time for the iPad to just totally shut off on me. And so I'm just going to do like probably objective 1 and 2 together and then stop that video, and then do like objectives 3 and 4 together and stop the video. Kind of do it in chunks, so that way if it decides to shut down again on me, I haven't just wasted 30 plus minutes, because it doesn't save it when it shuts down. Alright, so just so you know why there's a whole bunch of videos, in case I forget to tell you when I talk to you in class. Alright, so first thing we're going to do though, we're going to go back and forth with some notes today. So you're probably going to want to get a separate sheet of paper so that you can take notes on it. Alright, so I'm going to pull up my sheet of paper here, and let's talk about some of the stuff we're going to need for rational functions. Alright, so objective 1 talks about domain. And so for domain is always negative infinity to infinity unless it has one of these restrictions. Now there's definitely more than these restrictions, but when we're talking about rational functions, these are the things we have to watch out for, okay? So the first thing we have to watch out for is if it's a fraction with x in the denominator. If x is in the numerator, no big deal, okay? But if x is the denominator, then we set that denominator not equal to 0 and solve. So for example, if I have 1 over x plus 4, okay? It's a fraction, it's got x in the denominator, so you're going to set that denominator not equal to 0 and solve. So we'd subtract the 4, and we'd get that x cannot equal 4. Then I use a number line to help me. I always put my infinities, and I always put whatever it can't equal on here. Okay, if it can't equal that, that means it's going to be an open circle. But if it can't equal the negative 4, that means it can equal everything else. So everything I shade is going to be part of my answer. And so I can see that I've shaded from negative infinity to negative 4, and then we'll put that union symbol. And I shaded from negative 4 to positive infinity. Just make sure the negative 4 has parentheses on both of them, because it's not included. Alright, the other thing you have to watch out for is if you have a even root radical. So even, remember, even numbers, 2, 4, 6, 8, 10, etc. Root radical, so like if I have a square root, a fourth root, a 10th root, a 100th root, okay? Those are all even roots. Odd roots don't matter. Even roots we have to watch out for. Okay? If it's an even root radical, you're going to set the radical greater than or equal to 0. So if I have the square root of x plus 2, then we're going to set that radical greater than or equal to 0 and solve it. So I would square both sides. So I'd have x plus 2 is greater than or equal to 0, subtract the 2, and so we get x is greater than or equal to negative 2. And again, I would use my number line to help me. So I put my infinities and my negative 2 on here. Now we said x is greater than negative 2, so that goes this way, or equal to, so we'd use a bracket. And so I can see right here with my shading that it goes from negative 2 with a bracket to positive infinity, and that would be my domain. And then the other one you have to watch out for is if you have an even root radical in the denominator of a fraction. So it's kind of where we put them together. So even root radical in the denominator. So if I have, in this case, you would take that radical and you'll set it greater than 0, okay? So if I have 1 over the square root of x minus 3, and I'm going to be crazy here, put plus 2. Now, let's not worry about the plus 2 yet. Alright, so I have an even root radical in the denominator, so I'm going to take that radical, so the square root of x minus 3, and I'm going to set that greater than 0, okay? Just no equal to, because remember, the denominator can't equal 0, so it's kind of like putting them together. Alright, so the square both sides, so we get x minus 3 is greater than 0, add the 3, we'd say x is greater than 3. And so if you need to, use a number line. Guys, I'm big on being able to use my number line when I need it. Okay, it's going to be greater than 3, so it's this direction, but it's not equal to, so it's a parenthesis. So then my domain would be 3 to infinity with a parenthesis, so it's not included. The only other thing I've seen sometimes you have to watch out for is if they put a radical in the numerator of a fraction, but they still have x in the denominator. In that case, you work the fraction part, like number 1, you take the denominator, set it not equal to 0 and solve. You take the radical, you do like part 2, you set it greater than or equal to and solve, and then you find what makes them both true, okay? So I would graph them both and see where do they overlap, and wherever they overlap will be what your domain would be. We don't see those very often, but it could show up. Alright, so now let's go back to our notes. And let's look at objective 1. So it wants us to find the domain. Alright, so find the domain of g of x equals x over x squared minus 25. Alright, so domain only deals with the denominator if we have a fraction, okay? Numerator does not matter on a fraction unless it's a radical, okay? So we know that the domain, that x squared minus 25 cannot equal 0. Well, there's a couple ways to work this, and I'm going to work it one way on 1a, and I'll work it one way on solve problem 1a, and a different way on pencil problem 1a. Alright, so one way to do this is we can factor this. X squared minus 25 is the difference of squares. So remember, you take the square root of them both, so x squared and 5, you add one parenthesis, and you subtract in the other parenthesis. Okay, not equal to 0. And then just like what we were doing before when we had multiple factors and we set them, it was equal 0, we set them each equal to 0. We're going to set these each not equal to 0. And solve them both. So the first one tells us that x cannot equal negative 5, and the second one tells us that x cannot equal positive 5. So to write this in interval notation, I'm going to use the number line to help me. So I got my negative and positive infinity, and I need to put both of those numbers up there in numerical order. So negative 5 and positive 5, and we know it cannot equal them, which means it can equal everything else. And so I can see I'm going to have 3 intervals here. I'm going to have right here, so negative infinity to negative 5, union, then negative 5 to 5, union, and then 5 to infinity. And so there is our domain. Now for pencil problem 1a, it's the same idea. It's a fraction with x in the denominator, so we know that that denominator cannot equal 0. Well, some of y'all are like, well, why did you factor it? Why didn't you move the 25 on the other? Well, we could do that. We could just move in this one, move the 49 over. And so you get x squared cannot equal 49. Take the square root. Just be really careful, because remember, anytime you're solving for x and you take a square root, you get plus or minus, okay? And the square root of 49 is 7. So it's the same thing. X cannot equal positive 7. X cannot equal negative 7. So if I use my number line to help me, so I got to put negative 7 and positive 7 in numerical order. It can't equal them, which means it can equal everything else. And so we got from negative infinity to negative 7, union, negative 7 to 7, union, and then 7 to infinity for our domain. Alright, solved problem 1b. We got kind of the same thing. We have a fraction with x in the denominator, so we know that our denominator cannot equal 0. I can't factor this one. If they're squares, They have to be a difference of squares, and this is a sum. So I'm just going to have to solve it like I did the previous problem. So we get x squared cannot equal negative 25. Take the square root, and we get x cannot equal plus or minus the square root of negative 25 is 5i. Now when we're talking about domain, guys, we're talking about, remember, domain is our x's. So we're looking at our x-axis. Do we have a positive 5i or a negative 5i on that x-axis? We do not, okay? So what this is saying then is that there is no real number for x that if I plug it in, square it, and add 25, it will ever equal 0, okay? So because there's no number that'll do that, our domain is actually negative infinity to infinity. And then pencil problem 1b, same idea. We're looking for domain. We have a fraction with x in the denominator. So our denominator cannot equal 0. Again, we cannot factor this as a sum of squares. So we're going to just move the 49 over. So x squared cannot equal negative 49. Take the square root. And so x cannot equal plus or minus 7i. Because it can equal an imaginary number, that means our domain is negative infinity to infinity. Notice both of these were sums of squares. Anytime you have a sum of squares in your denominator, your domain is going to be all real numbers. Alright, and so actually that one took me a little longer than I thought, so I'm going to stop this video and we'll start with objective. Well, no, let's go ahead and do. No, I'm going to stop it. I don't want to take a chance that we lose it.